Hello, everybody. This is Jason from Children's Museum Houston. I am the Science Outreach Manager as well as a Life Science Educator here at the museum. And today I have some very cool guests with me. I have Michael from Premier Oilfield Group and his daughter Rachel, and they are going to do a really fun activity with us. So say hello, everybody.
Hello.
All right, Rachel, how old are you?
My name is Rachel, and I am in fourth grade at Travis Elementary.
And you're how old?
9.
You're 9? All right. And Michael, you are, I assume, a geologist, yes?
I am, yes. Don't ask me how old I am.
I will not ask you that, but I will ask this. What inspired you to become a geologist?
That's a good question. I was actually studying math, and I took a geology course, and I loved the connection to nature, but I also felt like geology was just a giant crime scene. It was just like trying to figure out what happened and then applying that knowledge. So I was kind of hooked from my sophomore year in college.
Cool. And you work for Premier Oilfield Group, yes?
Yes.
And what exactly do you do with them?
So Premier Oilfield Group, we're an oil field service company. We don't look for oil, drill for oil, explore for oil. We do laboratory analysis to help the oil companies understand the rock samples they take. So what we do is we can do a whole bunch of different analyses to help them understand the best way to get the oil and gas out of the reservoir. So my part is I actually look at the rock. So I use all the techniques where you actually describe the rock, you look at it with microscopes and minerals and elements and all kinds of things like that. So I'm kind of very focused on the rock samples.
And if I am correct, and again, correct me if I am wrong, you are looking for sedimentary type rocks for the most part when you're looking for oil, yes?
That's correct. There are only a few rare instances where oil is found in other than sedimentary rocks. A few volcanic rocks, a few kind of granite-like rocks, but it's very rare.
Okay, so I am understanding that you're going to do a very cool activity for us that talks about both cementation and compaction, or is it the other way around?
Well, so what we're going to do is we're going to talk about sediments, sand, silt, clay, sand and mud, and how they go from being loose sediment all the way to being hard rock.
Okay, take it away, my man. You got this.
Okay. Thank you very much. So what we want to do is first, let's just look at what we're talking about here. I've got four samples of sand here. This is a pebbly river sand. Here's another river sand. Here's a beach sand, and here's another beach sand. This is sand. It's loose. You can pick it up in your hands. Okay. So how do we get from here to here? Okay. These are all pieces of sandstone. They're different colors because slightly different minerals. Anytime you have red, you usually have some kind of hematite or iron oxide, but these are extremely hard rocks. How do we get from here to here? And that's one of the things we're going to look at today. Also, so the sand is the coarse stuff, the gritty stuff you can put in your hands, right? One of Rachel's favorite things in the world is not so much sand as mud. So this is mud. We've got some sort of fresh mud. I dried it out a little bit. And mud is finer grain material. Okay. So let's bring our poster for grain size over here. Great. Thank you. So this kind of illustrates the concept that geologists and engineers have used for 100+ years. So we've got sand over here, it's coarse, okay? The definition is it's greater than 0.06 millimeters, but it's just coarse, it's gritty, you can feel it with your hand. Silt is in between, and clay is the kind of squishy minerals that we're all familiar with, like with our feet in the mud or squishing with our hands, and that's what most of this is here. So it's sand, silt, clay. These are the sediments we start with, coarser grain to finer grain here. So, thank you. So here's our mud. The mud eventually gets buried and it's made into hard rock. So here's actually a famous shale that's producing a lot of gas right now. Had a lot of organic matter in it. That's how it generated the gas. Here's some other types of shale. So what we're going to do is we're going to say, how does this get here? How does this get here? Okay. So what we're going to do, first of all, let's bring the compaction squishing So to understand how sediments get to be rocks, you kind of have to pay attention to these three things. Okay? So first is the sediment is compacted. What's the other word for compaction?
Squishing.
Squishing is, I understand, is probably the clearer word. So that means when sediment gets deposited and buried and buried and buried deeper and deeper, it has heavier and heavier amounts of sediment on top and it gets squished. Okay, so that's compaction. For some rocks like shales, that's almost enough to make it hard, but for other rocks, that's not enough, like sandstones. The second is what we call cementation.
Or gluing.
Gluing, okay. So what that does is there actually, as the rock is being compacted and buried, there are actually new minerals that form in the pore spaces. What are pores?
Holes.
Pores are the holes. We always have to think about the pores in the rocks, okay? People, when they think about these rocks here don't have many pores left, but pores are a very important part of the whole system. Second, they're really important to people because pores are where there's fresh water, there's oil, and there's gas. And we extract those things to use. And now, you know, as we're moving toward things like trying to address climate change, we also are going to be putting CO2 back into some of those pores to try to get it out of the atmosphere. So pores are very important to people, okay? So, thank you, dear. Appreciate that. Okay, so first we're going to do a little experiment here to show how a lot more of the space you see as sand is actually pore space, okay? So I've made a 1 liter mark on here and I filled it up with sand, okay? So most people say, oh, it's a liter of sand, it's all sand. Well, interestingly, not so much. And Rachel's going to show you right now.
Ah, it's not filling up anymore.
So that's 250 milliliters of water. See how much more it takes.
Ah, I can see some seepage now. There it comes.
Here it comes to the top. And let me see, what do we have left? We had about 40 milliliters. So what that tells us, believe it or not, this space right now is about 46% pore space, holes filled with water, okay? And that's the way sand at the beach or sand in the river starts its life. It just has all that extra pore space, okay? So what happens is that gets compacted as we bury it. So we're gonna show you a little experiment. We can't compact this sand hard enough without breaking everything like in the real world. So we're gonna have kind of a model that shows us. Let's do the squisher first. Thank you. So we made a model here. Okay, so this is kind of like sedimentary rock layers. Okay, and they're slightly different sponges, so they have different amounts of pore space, but they all have pore space that's full of water. So we're going to illustrate here what happens when more sediment gets put on top of this. What happens? Go ahead, Rachel. Let's show you. So when sediments get buried, they get compacted and they actually squeeze that water out that goes back up into the system. So you're reducing the pore space, squeezing out the water. And that's a lot of water to squeeze out of those sponges. So let's pick that up for a second. So if we were able to compact the sand to the way it would be if it was buried 2 or 3 miles deep, we would take out at least 20 to 25% of the porosity just by compaction. So that would look something like this. This would all be solid sand, and this would be the water that would come out. Now with mud, it's even more dramatic. So if we start with a liter of mud, like you pick up at the bottom of the ocean, or like you could pick up in a swamp or the lake or in parts of the riverbed, when that gets compacted to death, that can be 60 to 80% of this to start with can be water, believe it or not. So it's water that gets squeezed out, and you're all the way down to this much.
Wow.
So deep, deep where rocks are buried, the way these things get so hard is they get compacted. The water gets squeezed out, and the clay minerals get squished together, which is usually enough. That's the main thing that will make shales hard. With sandstones, we still need more stuff. Okay, so that is the part where we talked about compaction. That's step one of taking sediment and making rock out of it.
Last thing, if you are watching this on YouTube, please hit the subscribe button. If you do that, you'll get notifications of all kinds of cool stuff that we're doing, like these live videos that we're doing with Michael and other people at Premier Oilfield Group. With that, I want to say goodbye to you. Hope you have a good day. And let's say goodbye to Michael and Rachel with big thumbs up and smiley faces and all that good stuff. Thanks a lot, y'all.
All right, thank you. Take care.